All right, today we're doing Chapter 2, Section 2, Order of Operations. And I'm going to start out with a phrase that pretty much is always used with this. It's please, excuse. I'm going to write it maybe a little differently than what you've seen before. I'm going to put my and dear one above the other like that. And then Aunt Sally. You can spell aunt either way. I kind of like it this way. I kind of picture that somebody with a little pet that they have on a leash or something like that. But anywho, this, if you take the first letter of each of those things, it stands for a math operation. And this is kind of the order that we do math operations in. So the P, I'm going to write a P real big, and then an E, and then an M and a D, one above the other, and then an A and an S. And those stand for parentheses first, and then exponents. Although we're not going to have any exponents in this chapter for us. That'll come a little bit later on in math. And the M would be multiplication, and then division, and then addition, and subtraction. And whenever we're taking something like these things down below, you have a whole bunch of numbers, you're trying to figure out what one number does it equal. You always take and do this left to right. So you'll first start with parentheses, then you'll jump over to exponents, then you'll do multiplication, division, and it's not multiplication first and then division second. You actually work from left to right. So whatever multiplication is the furthest to the left in a problem, you do that first. So we do like multiplication over here before we do multiplication someplace else. Actually, none of them really show it well, but if you had something like 2 times 3 divided by 4, you'd have to do the 2 times 3 first before you could do the divided by 4. And then the same sort of thing for addition and subtraction. If you had those in a line, you'd have to do the whatever's on the left first. I want to throw one thing else out there. I've seen some efforts at changing this P for parentheses. And actually right now in my classroom, instead of a P, I have a G written up there. And G stands for grouping symbols, because a lot of times there's kind of understood that there's parentheses someplace, but there's not. So you could kind of do either thing as far as I'm concerned. It's a little easier to remember perhaps with a please excuse my dear Aunt Sally than like GEMDAS or something like that, GEMDAS. But what we mean by that is sometimes you'll see parentheses like this. Sometimes you'll see parentheses inside parentheses, and they'll use like square brackets. Those also count as parentheses. Or even like the curly brackets. Those are parentheses. So that's an option that you'll see any one of those three. Other options are going to be places where they just kind of assume that there are parentheses. If you have absolute value of some number, it's kind of like there's parentheses inside that absolute value. You have to do what's inside the absolute value before, so you have like 3 times that. You have to simplify what's inside the absolute value before you multiply by 3. Or a little bit later in life, you're going to start getting like radicals, like square roots and things like that. And you could have multiple things in there like this, but you have to first, before you can do the radical, you have to combine all those, the 4, the 5, and the 2 into just one number. And something that's a little bit more what you guys have been seeing is like a fraction. If you have 4 plus 5 over 3 times 8, you can't just do the division right away. First you have to get the numerator into one number, get the denominator into one number, and then you could actually divide. So some people may call it grouping symbols, some may do parentheses, but either way you have to notice that sometimes, even though they might not write the parentheses in there, just have 4 plus 5 over 3 times 8, that you do have to simplify those as well. I wouldn't get too caught up in that, so if I'm kind of making your head spin, maybe see if you can store that in the back of your brain somewhere, but really I wouldn't worry about that in this chapter, in this section. Okay, let's do this next one then. The reason we have these, though, is because order matters. If we didn't have this set of rules, 2 people could do this same problem right here and come up with 2 different answers. So we have to have a certain order to combine numbers in so that as you write something, there's only one correct answer. All right, so I'm going to have this please excuse my dear Aunt Sally still on the screen. And I'm going to drop it down just a little bit. And so I'm going to start out with, all right, as I work through it, are there any parentheses? Nope, there's no parentheses, no grouping symbol, so it's kind of like that's just gone. No exponents, we said in this section. But now we have multiplication and division. So my first step is I have to do my 4 times 5, and that gives me 20. So I'm going to recopy everything down. People that recopy everything are way more likely to get it right. So that's what I'm going to ask to see in your homework, to kind of work vertically and to kind of copy things down from line to line as you keep simplifying. All right, so now we're done with all of our multiplication divisions. Now we have addition and subtraction. And we can just add those two together. 2 plus 20 gives me 22. So there's my final answer. All right, we jump over to the next one. So I'm going to go with, please excuse my dear Aunt Sally. And this time we do have parentheses. So we can start with the parentheses in this first step right there. And 2 plus 4 gives us 6. So we have a 6. Then we'd copy down the times 5. And parentheses are done. There's no exponent, so now we're up to multiplication and division. So that is a 30. So final answer, 30 on that one. If we would slide the page up a little bit. All right, and I'm going to write out my order of operations. Please excuse my dear Aunt Sally. And it's a pretty good idea to write these things. I'd encourage you to do it, especially if you find you're getting some of these wrong. But parentheses, in some respects, it's like, hey, look, there's no parentheses. But like I was showing there in the upper right, that when you have a fraction, it's like there's parentheses around the numerator and the denominator. We don't really need it in the denominator because there's only one number. There's no operation to do there. But we do have to do the 5 plus 3, and that'll give us an 8. So if we do the 5 plus 3, 5 plus 3, so that gives us an 8. Now we're done with our parentheses. Oops, write the whole thing, Falk. So 8 over 2. No exponents. Now multiplication and division, yep, that's what we're on. We're dividing, and 8 divided by 2 is 4. And some people don't like that you're going to be taking up more lines in your paper doing it this way, but you could do a couple columns, to maybe even 3 columns if you wanted to on your sheet. And that'll help save space on paper also. All right, so have this one here. And a lot of people, they start to stress out about it, but you just kind of take it in order. Just do it step by step. All right, so we need to take and get all of this part here down into one number. And just like that last one, when we have a fraction, it's like there's understood parentheses there in the numerator. So normally, as we do parentheses, we have to go through and do these steps in order, but really, there's only one thing there in the numerator that we have to do first. We have to do our 7 plus 13. That gives us a 20. So I have 20 divided by 5 in my parentheses. And then 3 times that, and a minus 9. All right, now my next step, we're still kind of working here in this parentheses part. 20 divided by 5, well, we could say that's 4. So I'm going to rewrite it as 3 times 4 minus 9. And now we are done with parentheses. So no exponents in this section. So multiplication division comes next. So 3 times 4 gives us 12. So now I have 12 minus 9. We're done with multiplication division. So last step is we do subtraction, and we get 3 for our final answer. Now the beautiful part about writing out steps like this is, one, you're way more likely to get it right, especially when you get these long problems. The people that just take 7 plus 3 and they write 20 down somewhere on the side and then try to remember what to do with it, they tend to miss stuff in the bigger ones. Second, if you do make a little mistake, chances are I can take off a half a point instead of when you just give me the final answer and no work, then it's like 2, maybe 3 points off on your quiz or test, and that just really kind of decimates your grades. Okay, this last part of your section, I'm just going to hit really, really briefly. And some of these you've probably seen before, and I'll probably go more in depth later on. They keep coming back around. But commutative property of addition and multiplication simply means that it doesn't matter if you have 2 numbers and you're adding them or multiplying them. The order you do it doesn't matter. In other words, for addition, 2 plus 3 is 5. That's going to give you the exact same answer as if you do 3 plus 2. Either way, you get 5. Multiplication, same sort of thing. 4 times 5 equals 5 times 4. Either way, you're going to get a 20. And that only works for addition and multiplication, not for subtraction or division. And the way I always kept that straight is commutative. It's kind of like communication. So I kind of look at it as person one is talking to person two, and then person two says something back. Kind of like, hi, how are you today? And then they all respond, I'm great, how are you? So as you can maybe remember it that way. Associative property multiplication and addition works for what order do you combine numbers in? So in this case, if you have 2 plus 3 plus 4 equals 2 plus 3 plus 4, it's saying that, well, you could add 2 plus 3 first, and then get 5 plus 4 gives you 9. Or you could add the 3 plus 4 first and have 2 plus 7, which will also give you 9. So you're going to have same result either way. And that works as well for multiplication. If you had 2 times 3 times 4 and 2 times 3 times 4. You could multiply 2 and 3 first. You could multiply 3 and 4 first. Either way, you're going to get the same answer of 24, I believe. All right, last step. For distributive property, you're really only doing this for numbers. A little bit later on in life, you get to up the ante a little bit. You get to do it with some variables, and that's really kind of fun. But okay, so for now, what they're saying is if you have 3 and then a parentheses and a 4 plus 5, you could look at this one of a couple different ways. You could say, all right, I have 4 plus 5 is 9, so I'm doing 3 times 9 to get a 27. But would you agree, when you take and change this 4 plus 5 into 9, 9 kind of includes both the 4 and the 5. So when we multiply by 3, essentially you're both multiplying the 4 and the 5 by 3. Well, distributive property says you can do that kind of individually if you want to look at it that way. You could say this, maybe I'll just rewrite it, 3 and then a 4 plus 5 in parentheses. They're saying you can multiply the 3 times the 4. When we do that, we get a 12. And you can multiply the 3 times the 5. Technically, it's kind of like a positive 3 times a positive 5 right there. And when we do that, we're going to get a positive 15. And then if I add these two together at the end, instead of at the beginning, I get 12 plus 15, same answer of 27 as what we had before. So that's the distributive property, that you can take and either combine the two numbers first, like this here, into 9, multiply both of them by 3 this way, or you could multiply both numbers by 3 separately and then combine them afterwards. So you'll see some of this distributive property stuff in there too, so check that out, and let me know if you have any questions. Thanks, guys.